Hey guys, it's me, Miss Mills, and welcome to Miss Mills Math Time. The whole point of this video is to help you out with different types of solutions notes. Again, these notes are interactive, so you do have to watch the video and follow along in order to get the answers and some in-depth explanations as well as some other stuff. So, the video is going to be on the second slide, and let's go ahead and talk about this. So, different types of solutions, what this note is basically going to tell you is that on our last notes in the last IXL, you solved a system of equations by graphing. And each time you had one solution, okay? Well, there are different types of solutions, and I wanted to show you that some of them you can solve without doing anything, just by observation. So that's what we're going to talk about here. There are three different types of solutions, so let's talk about those. So the first one is obviously, wow, I moved the whole thing, is one solution. We've already figured that out. When you when you graph two equations, you found that there was one point where they both met up. Therefore, there was one solution. So when you're going to see that is, so right here it says, when would you see that? What you're going to write down is, if you look right here, it tells you this only happens when the slopes are different. So what you're going to do is you're going to copy that and you're going to paste it right there. It saves you some time and effort. So one solution, when would you see that? You're going to see it when the slopes are different. Okay? No solutions. This is when you would see it, something that has no solution. So in this particular case, if you see no solutions, sorry, I'm going to back up real quick. An example of one solution is what we did on the IXL. It's where you have two lines and you find one ordered pair where they meet up. Okay, so it says two lines intersect one time, therefore it has one solution. Okay, so now, no solutions. When would you see that? So an example of something with no solutions is when you would plot both lines and they're parallel to each other. That means that for infinity, they're never going to meet up with each other. Never, ever, ever. Therefore, there's never going to be a solution. The only time you're going to see that is when you have the same slope. So this is very important. If you see two equations with the same slope but different y-intercepts, that's going to be an example of something with no solution. So you can go ahead and look at your equations. You can look at them and be like, hey, do these have the same slope? If they do, and they have two different y-intercepts, they're never going to meet up. Therefore, they're never going to have a solution. And you don't have to do any graphing. You can just observe that, and then you're done. And then last but certainly not least, infinitely many solutions. As you can see, there's only one line here, so you're probably really confused, but you'll know what I'm talking about in just a second. Guys, when you have infinitely many solutions, what that means is that the slope and the y-intercept is going to be the same. So what that means is both equations are going to be the exact same line. The exact same line is going to, I guess the best way to say it is it's going to be the same line. They're always going to be like on top of each other. They're the same exact thing. They're never not going to touch each other. Therefore, this is going to have infinitely many solutions because both lines are initially the same line. So there you go. So the only time you're going to see that is if the slope and the y-intercept are both exactly the same. So if I gave you two equations, I'm going to do this. If I gave you two equations and you notice that the slope and the y-intercept are the same, you can just go ahead and say infinitely many solutions and you don't have to do any work on it, just observation. And that's all this is. The first slide, go ahead and copy and paste those to this first slide and you'll be good to go. So we talked about those solutions. Now, we're going to do two examples. So, as y'all remember, we just talked about how to graph lines. We reviewed how to graph lines. We're reviewing some of our equation stuff where we just solved equations, and we're putting it all together to solve systems of equations by yada yada. All right, so what we're going to do here is I'm going to write down both equations, and I'm going to see they're going to have one solution, no solutions, or infinitely many solutions. And honestly, I don't actually need this. I can solve these by observation. So this one right here is already in y equals mx plus b form. So the y-intercept is b, the slope is m. Okay, so now I want to see how this one matches up to this one. So to do that, I need to turn this into y equals mx plus b form. If you remember in our past videos, you can do that. This is how you do it. Your whole goal is to get y by itself. So what we want to get rid of first is this negative 4x. So we have to do the opposite of negative 4. The opposite of negative 4 is a positive 4. And if you do it on one side of the equation, you have to do it on the other side as well. Equal sign. So these cancel out, they're opposites. I'll bring down my plus 2y. Remember, these are not like terms, so they can't combine, so I have to write down the whole thing. And remember, I always put the x first because, it matches up with this, and I'm going to just save time by doing that. And now, I still need to get y by itself, so the last step is to divide everything by 2, because 2 is multiplied by y, the opposite of multiplication is division. Whatever I do on one side, I have to do it to everything on the other side of the equal sign as well. So I'll bring down this y. 4 divided by 2 is going to be 2x. 2 divided by 2 is going to give me plus 1. All right, so now I'm going to match these up. All right, as we can see, these both have the same slope, but they have two different y-intercepts. So this is what this is going to mean. If we go back to our notes, no solutions happens when the slopes are the same, but you have two different y-intercepts. So what that means is this is going to have no solutions. These are going to be parallel lines that are going to go on forever. They're never going to touch each other. So what I'm going to do, if I was a student, is right here, I'm going to click this. I'm going to copy it. I'm going to paste it over here. This would be an example of no solutions. So therefore, this would be an example of a no solutions graph. So I'm going to copy and paste it right here. They both have the same slope, but different y-intercepts. Therefore, they're going to be parallel lines that are never going to meet. Therefore, no solutions. Great. Let's do example number 2. Same thing. I'm going to write down both equations, and I'm going to match them up. And to match them up, I first have to solve the second equation by turning it into y equals mx plus b. So what that means is I want to get this y by itself. So first I'm going to get rid of this x. To get rid of a positive x, I got to subtract it. Whatever I do on one side of the equal sign, I have to do it on the other side as well. These cancel out. They're opposites. I'll bring down this 2y. Since these are not like terms, I have to write down the whole thing. This turns into negative x plus 8. Okay, since these are not like terms, I have to write out the whole thing. Do not mess that up. Now I need to get y by itself, so I got to get rid of this 2 multiplied by y. The opposite of 2 getting multiplied by y is to divide it by 2. Whatever I do on one side, I have to do it to everything on the other side as well. So these are going to cancel out. Negative 1 x over 2. Okay. So when you have this right here, that's going to turn into negative 1/2 x. Okay. And then 8 divided by 2 is going to give me plus 4. So now I'm going to match these up. Here are both equations. They're both in y equals mx plus b form, and I can match them up. As you can see, they have the same slope, and they also have the same y-intercept. So what that means, as these are exactly the same line. So what that means is we are going to put in here, I'm going to get rid of this bad boy, and I'm going to say these have infinitely many solutions because they're the same line. So I'm going to copy this, I'm going to paste it here, I'm going to move it over here. Guys, that's all you have to do for these notes. I just wanted to show you what the different types of solutions are, how to look out for them, and you should be good to go. Let me know if you have any questions on this. I'd love to help, and I will see y'all later. Bye.